In this video, we will discuss classes and objects. Introduction to object-oriented programming, need of class and objects, defining classes, constructing objects, and the characteristics of object-oriented programming that includes abstraction and encapsulation, overriding methods, inheritance and polymorphism, then models and packages, introduction to class, string functions, formatting strings. Introduction to object-oriented programming. Object-oriented programming enables to develop large-scale software and GUI effectively. This part introduces object-oriented programming, which will build a foundation that enables you to develop GUI and large-scale software systems. In this picture, you can create a GUI objects like using the object-oriented programming. So for example, the buttons like OK, cancel, and you can get some kind of the input strings, enter your name, that is the label, and for that you need a text field or the text box in order to get the name, and check boxes like that, whether it is a bold, italic, like that. Then radio buttons, red color, yellow color, like this. So these are the GUI tools. So you can develop some kind of the GUI systems using the object-oriented programming. Need of class and objects. Classes in Python provide a way to structure and organize code into reusable components. So the main use of classes to create a new reusable components. They facilitate code reusability, modularity, and maintainability by encapsulating the data, attributes, and functionality, that is methods, within the objects. They promote code organization, encapsulation, that is data hiding, inheritance, code reuse, and polymorphism, method overriding, and making complex system easier to manage and extend. Defining classes for objects. A class defines the properties and behaviors for objects. Object-oriented programming (OOP) involves the use of objects to create programs. An object represents an entity in the real world that can be distinctly identified. It may refer to any objects, any place, a person name, and etc. For example, a student, a desk, a circle, a button, and even a loan can be viewed as objects. An object has a unique identity, state, and behavior. An object's identity is like a person's social security number. Python automatically assigns each object a unique ID for identifying the objects at runtime. The object states, also known as its properties or attributes, is represented by variables called data fields. A circle object, for example, that has a data field radius, which is a property that characterizes a circle. A rectangle object has the data fields width and height, which are properties that characterize the rectangle. Python uses methods to define object's behavior, also known as its actions. Recall that methods are defined as functions. You make an object to perform an action by invoking a method on that object. For example, you can define methods name, getArea, and getParameter for circle objects. The circle object can then invoke the getArea method to return its area and the getParameter method to return its perimeter. An object is an instance of a class that you can create many instances of a class. That means you can create many objects for a single class. Creating an instance of a class is referred to as instantiation. The term and object instance are often used interchangeably. An object is an instance and an instance is an object. So both object and instance are the same meaning. If you want to create a class, the syntax is class name colon the name of the class. So that is a class template. Data fields, for example, radius, and the methods. Suppose if you want to find the area of a circle, perimeter of the circle, if you want to set the radius value, you can declare the three types of the methods or the function: getArea, getParameter, setParameter. So once you declared a class, you can create a object for that classes. How can you create an object for a class? By mentioning the class name, then object name. Circle is the class name here, and the object one is the object name. Under that you can define the data fields. So The syntax is circle object 1 data fields radius 1. Similarly, for the second object, you can create the second, third and so on multiple objects. Defining classes. In addition to using variables to store data fields and define methods, a class provides a special method which is known as init method. This method is also known as initializer, that is invoked to initialize a new object state when it is created. An initializer can perform any action, but initializers are designed to perform initializing actions such as creating an object data fields with initial values. So the meaning of initiation is to creating a objects and initialize the data value for that objects. Python uses the following syntax to define a class: class name, initializer, methods. So note that init method that needs to be preceded and followed by two underscores. For example, import the import math, and the name of the class is class circle. So class circle colon. First construct a circle object. So def init is the method. It takes two arguments, self and another one is radius, that is equal to 1. So this is the initializer. Then that self dot radius equal to radius. So you can create a data field for that objects. Def get parameter, this is the method. So it takes the self argument. So return 2 star self dot radius into math dot pi. So the pi, you know the value of the pi, it can be get it from the math functions. That's why you are importing the math functions. Get def get area of selves, return self dot radius star self dot, because pi r square, radius into pi value. Similarly for set radius self comma radius, here you can set the value of the radius, self dot radius equal to radius. Constructing objects. Once a class is defined, you can create objects from the class with a constructor. The constructor does two things. It creates an object in the memory for the class, and it invokes the class init method to initialize the objects. The first one is to create an object, and the next one is it will invoke the init method which is used to initialize the objects. All methods including the initializer have the first parameter self. This parameter refers to the object that invokes the method. The self parameter in the init method is automatically set to reference the object that was just created. You can specify any name for this parameter, but by convention self is usually used. The syntax for constructor is class name arguments. It creates an objects in the memory for the class. So objects and its data fields. It invokes the class init method to initialize the objects. The self parameter in the init method is automatically set to reference the object that was just created. So init self. So it points to the object. Constructing an object creates the object in the memory and invokes its initializer. So constructor, it constructs an object. So the object is created and it invokes the initializer. That means it will invoke the value of the object data fields. From circle, import circle def main colon. So it is used to create a circle with radius 1, circle 1 equal to circle. So print the area of the circle of radius. Circle dot radius is circle dot get area. Similarly, you can create a circle with radius 25, 125 and so on. So at the end, you can call the main functions. So you will get, so the 4 radius you have declared in the previous program. The first where the first one is it returns the value of radius 1 for the area of the circle 3.141 something. Second, the radius is equal to 25. Then the area of the circle is 1963.49 something. And a third, the radius is 125. Hence the area of the circle is 49,087.38 and so on. And the last one is the radius is 1000. So the area of the circle is 31,415.926 and so on. Abstraction and encapsulations. Now onwards, we will discuss the properties or the characteristics of object-oriented programming. The first one is abstraction and encapsulations. Class abstraction is a concept that separates class implementation from the use of a class. The class implementation details are invisible from the user. This is known as the class encapsulations. So as the user, it is invisible. They just use the class. They don't know the implementation details. Class implementation is like that, the black box hidden from the client. Class contract, that is the headers of initializer and methods. Client use the class through the class contract. Class abstraction separates class implementation from the use of the class. Class abstraction and encapsulations are two sides of the same coin. So we will see this class abstraction and encapsulation with one of the real-time examples. Many real-time examples illustrate the concept of class abstraction. Consider for instance, building a computer system. Your personal computer has many components like that: the CPU, memory, disk, motherboard, keyboard, fan, power supply, and so on. Each component can be viewed as an object that has properties and methods. To get the components to work together, you need to know only how each and every component is used and how it interacts with the users. You don't need to know how the components are internally working. The internal implementation is encapsulated or hidden from you. You can even build a computer without knowing how a computer is implemented. This is known as the class abstraction. So everyone, they know how to use the computer, but they don't know how the internal parts are working. So this concept is known as the uh, class abstraction. Actually, the internal implementation is hidden. Only they can use the computer. Inheritance polymorphism. Object-oriented programming allows you to define new class from the existing classes. This is called the inheritance. Real-time example, we are a human being. We can acquire some of the uh, mm, characteristics or the properties from our parents, grandparents. So we have inherited some of the properties from our ancestors, and some of the new characters is also with us. This is known as the inheritance. Inheritance extends the power of the object-oriented paradigm by adding an important and powerful feature for reusing the software. So the main use of the inheritance is reusability. Superclasses and subclasses. Inheritance enables you to define a general class, a superclass, and later extend to the more specialized classes, that is the subclasses. Inheritance enables you to define a general class and later extend to it define more specialized classes. The specialized classes inherits the properties and methods from the general classes. One real-time example is our grandparents. Uh, they they are the base class. If you take, they are the base class. Our parents are the subclasses. So the superclasses are our grandparents and the subclasses are our parents. So our parents inherited some of the properties from their parents, that is our grandparents, and we are the again another subclasses of our parents. So we generally inherited some of the properties from our parents as well as from our grandparents. So all those parents, the starting class, general class, that is the superclass, and all other classes which is inherited from the superclasses are known as the subclasses. Inheritance enables you define a general class and later extend to it define more specialized classes. In object-oriented programming terminology, a class C1 extended from another class C2 is called a derived class, child class, or subclass, and C2 is also a base class, parent class, or subclasses. Geometric object, color. So here we will create the superclass and some of the subclasses. Geometric object is the superclass. Color string is something, and field boolean. Geometric object, color string, field, by default it is boolean, whether it is filled or not filled. Get color string. So the color of the object, that is default, for example it is green, indicates whether the object is filled with a color or not. Default it is true. Creates a geometric object with the specified color and filled values. So get color, it returns the color. Set color, it is used to set a new color, and isFilled, it returns the filled property. Set filled, it sets a new filled property, and set string, str colon string, returning a string represents of this object. So this generic object, geometric object, is the superclass or the base class. Here you can create two or more subclasses. One is the circle and the another one is the rectangle. These two are the derived classes or the subclasses. It inherits some of the properties of the from the superclass or the base class geometric object. So circle, it's the data field is radius, that is float, and circle, radius, float, color, str field, the same thing it can inherit it. Similarly for the rectangle, it consists the two data fields, width and height, and the other properties. So this is the simple program for using the base class and the derived class. Class geometric object, def init set color equal to green, self comma color equal to green, field is equal to true. That is geometric object class initializer and its data fields. Get color self, it is used to get the color, so it returns self color, self dot color. Set color, this method is used to set the color, so self dot underscore color is equal to color. And is filled, by default it is true whether it is written filled with some colors or not. And set filled, it is used to set the filled colors. And def string self str self return color self color and filled str self underscore filled. So here also the same program. This is the full program. Circle from geometric object.py. From geometric object imports geometric object, import math. Math.py is used in this class because in order to find the area. So the subclass, superclass, both classes, it uses the class circle geometric objects. Both it uses. Overriding method, this is the another properties. To override method, the method must be defined in the subclass using the same header as in its superclass. A subclass inherits methods from a superclass. Sometimes it is necessary for the subclass to modify the implementation of a method defined in the superclass. This is referred to as method overriding. For example, the previous program, the str method in the geometric object class returns the string describing a geometric object. This method can be overridden to return the string describing a circle. To override it, add the following new method in circle from geometric object.py program. So this is the coding. So the str method is defined in the geometric object class and modified in the circle class. Both methods can be used in the circle class. To invoke the str method defined in the geometric object class from the circle class, use super. Similarly, you can override the string method in the rectangle class as follows. So def and str self return super dot str plus width. So for the rest of this part, we assume that the str method in geometric object class has been overridden in the circle and rectangle classes. Polymorphism. This is the another property of object-oriented programming. It means that an object of a subclass can be passed to a parameter of a superclass. So the object of subclass can be passed as a parameter of the superclass. A method may be implemented in several classes along the inheritance chain. Python decides which method is invoked at runtime. This is known as dynamic binding. So this is the sample program. So from circle from geometric object import circle, from rectangle from geometric object import rectangle. So here you can declare the main method which is used to display the circle and rectangle properties. This is the entire program. And the next one is models and packages in Python. In Python, models and packages are fundamental concepts used in organizing and structuring code efficiently. Here is an overview of both. Models in Python. A model in Python usually refers to a structured representation of data or logic commonly used in fields like machine learning, databases, and web applications. Types of models in Python. Machine learning models. It builds using libraries like uh, scikit.learn. This is for the linear regression, random forest classification. TensorFlow, Keras, this is used for deep learning methods, and PyTorch, it is used for neural networks. So these three libraries are used for machine learning. Database models used in object relational mapping, that is ORM frameworks like SQL, AIChemie for relational database, Django ORM, that is for the Django apps. Third model is for the mathematical and statistical domain, built using libraries like stat models for the statistical analysis and SymPy for symbolic mathematics. And the last one is custom models. In software design, a model is simply a Python class that represents real-world entities. So example, machine learning model Python from sklearn.linear underscore model import linear regressions. So you can create a model is equal to linear regressions. So you can train the model x is equal to 1, 2, 3 and y is equal to 2, 4, 6. So you can model dot fit x comma y. So it print model dot predict of 4. So the output is 8. So it will create 1, 2, 1, 4, 1, 6, 3 and 2, 2, 2, 4, 2, 6 and 3, 2, 3, 4, 3, 6. Django database model from Django.db import models class book models.model colon title models.character field maximum length is equal to 100, that is for the title, and the author maximum length is equal to 50 and published date field. Packages in Python. A package in Python is a collection of modules that helps organize and reuse the code. Creating and using Python's packages. A package is a directory containing a special _init_.py file that can be empty. It allows grouping related modules together. For example, creating a package, my package, then _init_.py, then you can create so many modules under this. module1.py. So just it returns hello from module1. Then module2.py, it just add two numbers a comma b and return a plus b. Importing and using a package. So Python from my package import module1 comma module2. This is the way to how to import the modules in a package. Print module1.greet. This is the method which is defined inside the module1. Then add method that is defined in module 2. So it will print hello from module 1. Second one is print module 2 dot add of 5 comma 3. So 5 plus 3 8, that is the output of this program. Popular built-in and third-party packages. Built-in packages OS, that is operating system functionalities. Sys system specific parameters and functions. JSON parsing and mathematical functions. Third-party packages NumPy, numerical computing, pandas, data analysis, matplot library for data visualizations, request, HTTP request. Installing a package, so sh shell pip install numpy. Using an install packages Python, import numpy as np. Array is equal to np.array of 1 comma 2 comma 3 print array. So you will get the same numbers which are in that array 1 2 3. Key differences between models and packages. uh, Generally, models represents the data structures, logic or learning systems, and the packages is a collection of modules for code organizations. Modules are generally used in machine learning, databases or custom business logic. Packages helps structure and reuse Python modules. Example for the models that includes Django models, Scikit for the learning models, and packages NumPy, Pandas and HTTP request. Introduction to string class. Str object is immutable, that is its content cannot be changed once the string is created, that is immutable. Creating strings, you can create strings by using the constructor as follows. S1 is equal to string of, so create an empty string with empty string object. S2 is equal to string of welcome, so it create a string object and its value is welcome. Python provides a simple syntax for creating an object, string object by using a string value. For example, s1 equal to empty string. So this is similar as s1 is equal to str of this, s2 is equal to welcome, same as s2 is equal to str of welcome. A string object is immutable. Once it is created, its contents cannot be changed. To optimize performance, Python uses one object for strings that have the same content. S1 welcome, S2 welcome, ID of S1, it will return this one, ID of S2, so it will return the same thing. So Python uses one object for strings that have the same content. So this is the things. X is equal to 10, Y equal to 10, ID of X and ID of Y. If you print this, both the things, both IDs are same. Functions for strings. Len function to return the number of the characters in a string, and max and min functions to return the largest or smallest character in a string. So S is equal to welcome, len of S. So 7 characters are there in welcome, so it will return 7. Max of S and min of S. So it will return the maximum and the minimum characters in the string. S is equal to input, enter a string. If length of x percentage 2 equal to 0, print contains an even number of characters, else print s contains the odd number of characters. And the next one is index operator. A string is a sequence of character. A character in the strings can be accessed through the index operator using the syntax s of index. The indexes are 0 based, that is they can range from 0 to length of s minus 1. So the first index is 0 and the last one is the total length minus 1. So programming, S of 0 is P and the last one is G, that is the total length of the string is 11. So 11 minus 1, 10. So S of 10, that means it is the G, it denotes the G. S is equal to welcome for I in range 0 comma length of S comma 2, print S of I end. So it will print the characters from after it leaves intermediate characters W, L, O and E, like that. The slicing operator. So slicing operator returns a slice of the string using the syntax S of start colon end. The slice is a substring from index start to index and end minus 1. For example, S is equal to welcome S of 1 colon 4. So it will starting is the first, that is the index first. The index one is E and 1, 2, 3, 4. C is the fourth one, fourth index. C is the fourth index. So 1 to 4 ELC will be returned. Second examples, S is equal to welcome, S colon 6. So welcome. It will print a welcome first, that is 0, 1, 2, 3, 4, 5 totally. The 5 characters. 6 characters starts from 0 to 5 index. The concatenation plus and repetition star operators. You can join or concatenate two strings by using the concatenation operator plus. You can also use the repetition character star to concatenate the same string multiple times. So S1 is equal to welcome, S2 equal to Python. So if you want to concatenate this two string welcome to Python, S3 is equal to S1 plus 2 plus S2. So S3, welcome to Python. Suppose if you want to display welcome to Python in 3 times or welcome in 3 times, you can use the repetition operator, that is star, S1 star 3. So S1 is welcome, so welcome, welcome, welcome. 3 times it is repeated. The in and not in operators. You can use the in and not in operators to test whether a string is in another string. Here are some example. S1 is equal to welcome, come in S1, true. Come not in S1, false. So it is comes in S1, so it will return true. Here is another example. S is equal to input, enter a string. If Python is S, print Python is in S, else print Python is not in S. If you run the program by entering welcome to Python as the string, the program should display Python is in welcome to Python. Comparing strings. You can compare strings by using the comparison operators, that is relational operator double equal to. It will check whether it is equivalent to or not equivalent to, greater than or equal to, less than and less than or equal to. Whether it is true, then it will return true, otherwise false. All the comparison operators. S1 equal to input, enter the first string. S2 is equal to input, enter the second string. If S2 is less than S1, then S1, S2 is equal to S2, S1. The two strings are in the order S1, S2. Iterating a string. A string is iterable. This means that you can use a for loop to traverse all characters in the string. For loop the string sequentially. For example, the following code displays all the characters in the iterable string S. For ch in S, print ch. You can read the code as for each character ch in S, print ch. For loop does not use indexes to access characters. However, you still have to use indexes if you wish to traverse the characters in the string in a different order. For example, the following code displays the characters at odd numbered positions in the string. For I in range 0, len of s, 2, print s of I. The code uses variable I as the index for string s. I is initially 0, then incremented by 2 successfully before it reaches or exceeds the length of s. For each value, I, s of I is printed. Testing strings. The str class contains these methods for testing its characters. Is alphanum boolean returns true if characters in the string are alphanumeric and there is at least one character. Is alpha bool returns true if characters in the strings are alphabetic and there is at least one character. Is digit bool returns true if this string contains only number characters. Is identifier bool returns true if the string is a Python identifier. Is lower returns true if all the characters in the strings are lowercase letters and there is at least one character. Is upper boolean returns true if all characters in the strings are uppercase letters and there is at least one character. Is space bool returns true if this string contains only white space characters. So this is the sample program. It will returns based on the things whether it is a true or false. Searching for substrings. Ends with s1 str bool. It returns true if the string ends with the substring s1. Starts with s1 str bool. Returns true if the string starts with the substring s1. Find s1 int returns the lowest index where s1 starts in the string or -1 if s1 is not found in the string. Or find of s1 int returns the highest index where s1 starts in the string or -1 if s1 is not found in the string. Count substring int returns the number of non-overlapping occurrences of this substring. This is the example. Welcome to Python. S dot ends with ton, true. S dot ends with good, it's false. S dot find, come. Converting strings. Capitalized str returns a copy of the string with only the first character capitalized. Lower of string returns a copy of the string with all elements converted to lowercase. Upper string returns a copy of the string with all letters converted to uppercase. Title str returns a copy of this string with the first letter capitalized in each word. Swap case str returns a copy of this string in which lowercase letters are converted to uppercase and uppercase to lowercase. Replace old new string returns a new string that replaces all the occurrences of the old string with a new string. This is the sample program for the methods. Stripping white space characters from the string. Lstrip string returns a string with the leading white space characters removed. Rstrip string returns a string with the trailing white space characters removed. Strip str returns a string with the starting and trailing white space characters removed. Formatting strings. Center of width string returns a copy of the string centered within a field of the given width. Ljust of width returns a string left justified in a field of the given width. Rjust width of str returns a string right justified in a field of the given width. Formats the string format of items. Formatting strings. You can use the conversion code S to format a string with a specified width. So you can use 20s, less than 20s, greater than 20s. So this indicates the format specifier 20s specifies that the string is formatted within a width of 20. By default, a string is left justified. To justify it, put the symbol greater than in the format specifier. If the string is longer than the specified width, the width is automatically increased to fit the string. Format specifiers, these are the things. 10.2f, format the float item with 10 and precision to 10.2u, 2e with 10 and precision to this is the scientific notation 5d, integer item in decimal with 5, 5x, hexadecimal with 5, and 5o, octal with 5, 5b, binary with 5, 10.2 percentage. It's a format the number in decimal, 5, 50s, that is the format the string item with 50 less than 10.2f, left to justify the formatted item, greater than 10.2f, right justify the formatted item.